Hello dear friends, our today's topic is a very important reduction reaction which is called as Birch reduction reaction. In this reaction, addition of hydrogen atoms takes place on 1 and 4 position of an aromatic ring to give 1,4 dihydroderivatives. For example, when benzene is treated with the alkali metals like lithium or potassium or sodium in presence of liquid ammonia, in presence of alcohols like ethanol or isopropyl alcohol or tertiary butyl alcohol, the reduction takes place, that is, the attachment of two hydrogens takes place in such a way that one hydrogen is attached at one position and the second hydrogen is attached at the fourth position respective to the first hydrogen. So in this way, when benzene undergoes Birch reduction, it gives formation of this product which is called as cyclohexa 1,4 diene. Now in this structure, two double bonds are there, so we will call it diene. So when we start numbering, so this carbon will be number 1, 2, 3 and this will be 4. So though the double bonds are starting at position number 1 and 4, we will call it 1,4 diene. The cyclohexa stands for presence of this 6-membered cyclic compound. Now, two trends are observed over here. First is when electron releasing groups are attached on an aromatic ring. The electron releasing groups are like the groups amino, hydroxy, methoxy and alkyl group. When such groups are present on aromatic ring, they are found to decrease the rate of reaction, and such groups are found on non-reduced position of the product. Now let's look at this example. This is the starting material anisole. Now in anisole, the methoxy group is the electron releasing group and it is attached on this aromatic ring. So when anisole undergoes Birch reduction in presence of lithium and liquid ammonia and ethanol, the attachment of hydrogen takes place at this carbon and this carbon. So this will be position number 1 and this will be position number 4 over here in respect to the hydrogens, right? So it is found that the reduction is not take place on that carbon which contains or which is attached with the electron releasing group, but rather the reduction takes place on the adjacent carbon and on the fourth position respective to this hydrogen. So anisole on reduction gives formation of this 1-methoxy cyclohexa 1,4 diene. So let's look at the next example. Suppose we start with aniline and treat it with lithium and liquid ammonia and ethanol. Once again, the amino group is the strong electron releasing group. So this carbon does not undergoes the reduction. Rather, this adjacent carbon undergoes the reduction, and with respect to this will be the fourth one. So reduction takes place at this and this position. So when reduction takes place at this and this, the double bonds will be split out and a new double bond will be formed over here. So aniline will give the formation of this cyclohexa 1,4 dienamine. Let's look at the next example. When orthoxylene undergoes the Birch reduction, these two methyl groups are the strong electron releasing groups. So the reduction takes place at this carbon and at this carbon, which are at 1 and 4 position to each other. So ultimately these two double bonds will be broken down and new double bond will be formed at this position, and this will give the formation of this 1,2-dimethyl cyclohexa 1,4 diene compound. Now next trend is that when the electron withdrawing groups are attached on the aromatic ring, the rate of reaction is increased and such groups are found on the reduced position of the product. For example, when the starting material is benzoic acid, the COOH group, that is carboxyl group, is the electron withdrawing group. So when it is attached, the rate of reaction is increased, and in product this electron withdrawing group is found on that carbon which undergoes the reduction. So here this benzoic acid gives the formation of this cyclohexa 2,5-diene 1-carboxylic acid. Now in this case, the carbon which bears the COOH group will be carbon number 1. So this will be number 1, this will be 2, 3, 4 and it will be 5. So double bond are starting at position number 2 and at position number 5. So we will call it cyclohexa 2,5-diene 1-carboxylic acid. Let's look at the next example, benzaldehyde. Here again the CHO group is the electron withdrawing group, and when it is attached on benzaldehyde and when the reaction is Birch reduction, it is this carbon, means the carbon which hold the CHO group, and this carbon that will be the fourth position in respect to this first one. So this first carbon and this fourth carbon now undergoes the reduction over here. So ultimately when this carbon and this carbon undergoes reduction, these two double bonds will be broken down and new double bond will be formed over the second and the third position over here. So it will give the formation of this cyclohexa 2,5-diene 1-carboxyldehyde. Let's look at the last example, this example of nitrobenzene. The nitro group is very well known electron withdrawing group. So when nitrobenzene undergoes Birch reduction in presence of lithium and liquid ammonia and ethanol, the carbon which hold the NO2 group and the fourth carbon with respect to this undergoes the reduction, and this gives the formation of 3-nitrocyclohexa 1,4-diene. Now dear student, if you remember the priority order of the functional groups, the nitro derivatives are inferior to the alkenes. So ultimately we will start numbering with that carbon which hold the double bond. So if we start numbering from this double bond, so this will be number 1, this will be 2 and this will be 3 and 4 and 5. So double bonds are starting at position number 1 and at position number 4. So it is called as cyclohexa 1,4-diene, and the nitro group is on position number 3, so it is 3-nitro derivative. So that is all about the Birch reduction and its simple examples. So thanks for watching the video. Please like, share and subscribe. Thank you.